Hello everyone, welcome back to Physics with Ashwini. In the previous parts, we have understood motion in one dimension step by step, from basic concepts to equation of motion and motion under gravity. Now, today, this is the final part of this chapter, and in this final part, we are going to explore two very important and interesting topics: symmetry in motion under gravity and relative motion in one dimension. These concepts will help you understand motion not just from one point of view, but from different perspectives. So let's get started with the final part of this chapter. Any idea about symmetry in motion under gravity? What is symmetry? In a simple way, symmetry means equality. So, how do we consider that for motion under gravity? Let us see. Let this be the ground. Let us take a body which is projected upwards with initial velocity u. As we have discussed in the last class, the body will reach the maximum height where its final velocity becomes zero and it will fall down again back to the earth surface, right? Now, what is the time taken for this entire journey? Moving upward and falling back to earth surface? It's called time of flight, right? If I denote it as A, B, and C. So A to B plus B to C. So this entire journey time taken is nothing but time of flight. Now we'll do one thing. Let us assume, let just for our understanding. So let us consider this time of flight is 10 seconds. So can you tell me now what is the time taken for its upward journey, time of ascent? It will be 5 seconds. And for its downward journey also how much time? 5 seconds. It was starting with 0 second, 1 second, 2 second, 3 seconds, 4 seconds, and at the fifth second, it will be at its maximum height. Sixth second, seventh second, eighth second, ninth second, and at the time of 10 seconds, the body will be back on the earth, right? This is a position at first second, second, third one, fourth second, position at fifth second. Fine. Now, what is this symmetry in motion under gravity is? If you take upward journey distance traveled with downward journey distance traveled. We are just comparing the distance traveled in upward journey and downward journey. The distance traveled by the body in the first second in upward will be equal to distance traveled by the body in downward journey in the last second. That means at 10th second. Similarly, distance traveled by the body in last second in upward journey will be equal to distance traveled by the body in first second during its downward journey. Just go through what I have written. In the upward journey, first second distance will be equal to last second distance in downward journey. Similarly, in upward, last second distance is equals to first second distance. Is it only for first and last? No. Like if you take the distance traveled in second in upward journey, it will be equal to distance traveled in ninth second in downward journey. Similarly, in third second will be equal to eighth second. Similarly, in fourth second will be equal to seventh second. So this is what called symmetry in motion under gravity. I hope you are clear with this. Just see what we have discussed. These two cases are important, so I have written these two. During the upward journey, the distance traveled in first second will be equal to distance traveled in the last second in downward journey. Similarly, in upward journey, the distance traveled in last second will be equal to distance traveled in first second in downward journey. It doesn't mean that it is applicable only for first and last. It is applicable for in between time intervals also. Just memorize this concept, understand this concept of symmetry in motion. Clear? Fine. We'll do one question on this. If a ball is thrown vertically upward with speed u, the distance covered during the last t seconds of its ascent. Ascent means upward journey. So a ball is projected upward. During the last t seconds, how much distance it has traveled? This is what our question is. Can we apply symmetry here? The distance traveled in upward journey in the last t seconds will be equal to distance traveled by the same body in downward journey in the first t seconds, right? Now, we'll use this concept. So let us take the body coming downward journey. So what will be its initial velocity for the first t seconds? 0. Time is t. Distance is question mark. Now use the formula ut plus half a t square. It is coming down, so distance is negative, so it is minus x or minus s. Coming down, so u is also negative, so this is minus 0 into t plus a is minus g t square. Now minus x is equals to minus half into 10 into t square. Minus minus cancel, 2 ones, 2 5s. So what is the answer? X is equals to 5t square. So this is the distance traveled by the body during its descent in the first t seconds. That means this is also the distance traveled by the body during its ascent in the last t seconds. Okay, options are not simple. Options are in terms of g. So let us not simplify here. What will you get if you don't simplify from this step? X is equals to half, instead of 10 keep g only, half gt square. So answer is option number B. G value was not substituted, so keep it in the same way. Now have you understood this symmetry and how this is useful to solve the problems? Because if you take ascent journey, upward journey, finding the distance in last t seconds will be a bit difficult. So if you apply symmetry, it's the distance traveled in first t seconds in downward journey, which is very easy because in downward journey, initial velocity is 0. Easily you can find the answer. So certain concepts are very important. They will save your time. So try to understand them. I hope you are clear with symmetry with this problem. Now we'll see the next concept, Galileo's law of odd numbers. Read this point. Successive distances, successive, one after the other, covered by a body dropped, that means initial velocity 0, from some height in equal time intervals, that means time gap is same, will be the ratio of odd numbers. What does it mean? Let us consider a body which is dropped. That means initial velocity is 0. Imagine after 1 second, this is the position of the body. After 2 seconds, this is the position of the body. Then after 3 seconds, this is the position of the body and it continues to move further. Now, if I see the time gap here, 1 second. What is the time gap in between? 2 seconds minus 1 second, 1 second. And what is the time gap here? 1 second. So this is the meaning of equal time intervals. If it is equal time intervals, and if you see the distance here, let it be S1, let it be S2, let this be S3. What is this S1, S2, S3? Imagine A, B, C, and D, and so on. S1 is the distance from A to B, S2 is the distance from B to C, and S3 is the distance from C to D. So these are the successive distances. And how these distances will be, if I take S1 is to, S2 is to, S3 is to, S4 up to so on. You can take anything. This will be the ratio of odd numbers. That means 1 is to, 3 is to, 5 is to, 7 is to, 9 is to, and it will go on. And when this is valid, initial velocity is 0 and there should be equal time intervals, equal time gap, then the successive distances will be in the ratio of odd numbers. Try to understand this. If you have understood, we'll move on to the problems. This is important while solving SNth also. In the previous classes, we have studied the ratio of SNth, like S fourth second to S third second, and we applied U plus A by 2 into 2n minus 1 formula, right? So instead of that, you can apply Galileo's law of odd numbers also. This will give you answer much faster. How it can be applied, we'll see. So are you clear with this? Successive distances will be in the ratio of odd numbers for a body whose initial velocity is 0 and traveling with equal time gaps. Okay, I'll erase this later. See this question. A stone falls freely under gravity. Falls freely. That means what? What about its initial velocity? For a freely falling stone, initial velocity is 0. It covers distances h1, h2, h3 in the first 5 seconds, next 5 seconds, and the next 5 seconds. That means there is an equal time gap. The relation between h1, h2, h3. Don't you think this is Galileo's law of odd numbers? So what can I say? H1 is 2, H2 is 2, H3. These are the successive distances and equal time gap 5 seconds, 5 seconds, 5 seconds. So this will be in the ratio of odd numbers 1 is to 3 is to 5. Now if I take H1 is to H2, how much is it? 1 is to 3. That means H1 upon H2 is 1 by 3. So what is H1? It is H2 upon 3. This is there in option D. If you want, you can verify H1 to H3 relation also. H1 is to H3 is how much? It is 1 is to 5, right? So 1 upon 5. This implies what is H1? It is H3 upon 5. So answer is option D. There are no other options with H1 is equals to H2 by 3. So directly you can go for option D. Easy, right? Now, see this question. A particle starts its motion from rest. That means initial velocity is 0. Under the action of a constant force, if the distance covered in first 10 seconds is S1 and that covered in the first 20 seconds is S2. Imagine this is the starting point A. For the first 10 seconds, let the position be B. And how much is the distance travel? S1. Then in the first 20 seconds, that means starting from A again, first 20 seconds, let the position be C. How much is the distance travel? S2. Now, if I ask you what is this distance and what is this time from B to C? First 10 seconds is S1, first 20 seconds is S2. So, what about this distance? Hmm? Can I say this is S2 minus S1 and this is 10 seconds? Can I say this? Total distance is S2. So what about this BC distance? S2 minus S1. Total time is 20. So what about the time from B to C? It is 10 seconds. Now apply this Galileo's law. successive distances S1 upon S2 minus S1 will be in the ratio of what? Odd numbers, right? So I can write it as 1 upon 3. Equal times, and these are successive distances, so their ratio will be in the odd numbers. Just simplify now. Do the cross multiplication. 3s1 is equals to s2 minus s1. Now 4s1 is equals to s2. Is there any such option? 4s1 is equals to s2. Yes, we have it in option B. So option B is our answer. Clear, everyone? Finding it useful? Galileo's law of odd numbers? Yeah. The water drop falls at regular intervals. That means time gap is same. This is the first drop. Again, one more drop. That means imagine these are the drops that are falling. First drop, second drop, third drop. And what about the time here? Time gaps are equal. From a tap 5 meters above the ground. So imagine this is the tap from which the drops are falling, and let this be the ground. So what is this height? This height is 5 meters. The third drop is leaving the tap at the instant the first drop touches the ground. So what is the condition here? Third drop is leaving the tap. At the same time, where is the first drop? The first drop is on the ground. This is first drop. This is third drop. Now, where will be the second drop? It will be here, right? In between 1 and 3. This is the second drop. How far above the ground is the second drop at that instant? So what we have to find here? We have to find this distance. This is the question mark. How much is the distance from the ground to the second water drop? That is the question. So what shall we do? It was mentioned regular time intervals. So if I consider this as H1, this is H2. What is this ratio? H1 is to H2. It is 1 is to 3 because equal times and equal successive distances. So odd number ratio. If I assume H1 as x meters, what will be H2 now? 3x meters. Now what is this total distance? H1 plus H2, x plus 3x, 4x. That is what? The height of the tap from ground, right? This total height. What is this total height? It is 5 meters. That means H1 and H2. So just simplify, how much will you get? So 4x is 5. Now what about x? X is 5 by 4 meters. Till this point, everybody clear? Now, what we have to find actually? We have to find H2, the height of the second drop from ground. What is H2? What is our H2? H2 is 3x, right? So just substitute now. H2 is equals to 3x and x is 5 upon 4. So how much will you get? 15 upon 4. So 4 3 is 12. 3 is left behind, 3 by 4. So 3 by 4 is how much? 0.75. So 3 plus 0.75, how much will you get? 3.75 meters. So answer is option A. Any difficulty? Just see the problem. Any difficulty? Let me know. Clear? Fine. What will be the ratio of distance traveled of a freely falling body? Freely falling body means initial velocity is 0. And it was mentioned again from rest. That means initial velocity 0 in 4th and 5th seconds of the journey. They are asking S 4th upon S 5th. Earlier, how did we do this? Yes, nth is proportional to 2n minus 1, right? Because initial velocity is 0, a by 2 is constant. And how did we do that? 2 into 4 minus 1 by 2 into 5 minus 1. 8 minus 1, 7. 10 minus 1, 9. So this is the answer. Now let us see how we can do this problem using Galileo's concept. First second, second second, third second, fourth second, fifth second. If I consider the respective distances S1, S2, S3, S4 and S5, what will be the distance traveled? It will be in the ratio of odd numbers, right? So 1 is to 3 is to 5 is to 7 is to 9. Now they are asking the ratio of what? Distance traveled in fourth to fifth second. So that is how much? 7 is to 9. So answer is option B. Finding it useful? They're asking for fourth and fifth seconds. That means the fourth odd number and the fifth odd number. That is 7 by 9. I hope you are clear with this concept. We'll do one more problem. The ratio of distances traveled by a freely falling body. That means initial velocity is 0 again. In first, second, third and fourth second. That means equal time intervals. So what will be the distances ratio? It is odd number ratio. So directly 1 is to 3 is to 5 is to 7. So that's what Galileo's concept. Now we will see relative motion in 1D. Take half minute time and just think, what is this relative motion? Relative means what? Comparing one with the other. Relative motion in 1D. Our chapter is motion in a straight line, so this is one dimensional concept. What is this relative motion? Let's understand. Let's this be the road. This is vehicle A and this is vehicle B. Imagine both are traveling in the same direction. This is velocity of A object and this is velocity of B object. Acceleration of A and acceleration of B. Imagine both are starting from this point. So what is this gap? This is displacement of A. Now similarly, what is this? It is the displacement of B object, right? Now if I ask you, what is the velocity of A object? What will be your answer? VA. What is the velocity of B object? Your answer will be VB. But if I ask you, what is the velocity of B object with respect to A object? Your answer is still VB. Is it still VB? Earlier, when you said VA and VB, those are the speeds of the object with respect to ground, but not with respect to each other. So, relative in the sense what? You are comparing the parameters of one object with respect to another object. Like you compare velocity of B with respect to A, displacement of B with respect to A, or acceleration of A with respect to B. You are comparing one with the other. That is called relative motion. Now, if I ask you velocity of B with respect to A, it is not VB. It is VB minus VA. This is the answer. So carefully observe, what have we done here? VB, that means we took the velocity of B minus VA. Don't you think we are reversing the direction of A? Then it becomes minus VA, right? In x-axis plus x-axis, it was VA. Minus VA means what? You are reversing the direction of A and you are adding it. So VB plus reverse direction of A. That means VB plus minus VA. That becomes what? VB minus VA. Very important. Have you understood this? So what we have to do is, ma'am, why did you reverse only A object direction? Why didn't you reverse B object? Important. With respect to whom are we taking the velocity of B? With respect to A, right? So A will become the observer. So we have to reverse the direction of observer. You are finding for object B with respect to whom? With respect to A. So A is seeing the B. A is observing the B. So A becomes the observer and observer's parameters have to be reversed. Observer parameters should undergo the change in direction. Understood this? Now I have a simple question for you. Let us take the same case, but this time let the object A is moving in negative x and object B was moving in positive x. Same speed VB, VA. Now what will be the velocity of B with respect to A? See, this is the notation. Velocity of B with respect to A means first you should write B, then you must write A. What letter you have written first? B. That means you are finding for B. Next you wrote A. That means A is the observer. So what we will do? We'll take the velocity of B. It is in positive direction, so plus VB. We will reverse the direction of A. Actually, where is the direction of A? Towards negative x. You have to reverse its direction. That means what should we do? We should take it along positive x-axis. Reversing is done. And now you have to add positive x, so plus VA. So what is relative velocity of B now? It is VB plus VA. Have you understood this? Most of the people also say like this. If objects are in opposite direction, we have to add them. If they are in same direction, you have to take difference of them. That is also fine. But my suggestion is, remember, observer's direction must be reversed and then it should be added, because this kind of concept will help you in solving 2D problems. Clear, everyone? So very simple. For relative motions, in order to take the formulas, my suggestion is observer's parameters like velocity, acceleration, displacement. First, change the directions. And second step, add them. Second step, add them. For example, object A moving like this, object B moving like this. Now, if I ask you what is velocity of B with respect to A, what should we do? Take the B as it is. Observer is whom here? A. So reverse the direction. Then it goes in negative x-axis and add them. So negative x-axis it is minus VA. So after addition also you'll get VB minus VA. Similarly, if I ask you acceleration of B with respect to A, same thing. Acceleration of B, acceleration of A after reversing it is minus A. So plus of minus A, it is minus A again. Similarly, displacement of B with respect to A, it is XB minus XA. Understand the concept. Later you can remember the technique. So what will you do? If both the objects are in same direction, take the difference for relative velocities, relative acceleration. If objects are in different directions, then take the sum of their parameters, like sum of the speeds, sum of the accelerations, and sum of the displacement. Clear? For 1D, second point is enough. But when you go for 2D, funda is important, concept is important. Clear? As of now, you can remember this for 1D. Objects are traveling in same direction, take the difference. If they are traveling in opposite direction, take the sum. Now see this question, just everyone fix in your mind. Same direction difference, different direction, opposite direction. Different in the sense here, different in the sense opposite direction. Opposite direction, then you have to take sum of them. See this question. A bus is moving with a speed of 10 meter per second. Fine. On a straight road. Okay. How much is the speed of the bus? 10 meter per second. A scooterist wishes to overtake the bus in 100 seconds. So in a time gap of 100 seconds, there is a scooterist going on the scooter. He want to overtake the bus. That means he also must travel in the same direction, right? The bus is at a distance of 1 kilometer. So what is the distance given here? 1 kilometer. 1 kilometer means it is 1000 meters. With what speed should the scooterist chase the bus? That means you have to find the speed of the scooterist. Let me denote it as Vs. And this is Vb, velocity of the bus. Have you understood the scenario here? Bus speed is given. You have to find the scooterist speed. Time is given. Distance is given. So what shall we take? Velocity is equals to distance upon, displacement upon time, right? But what will you do here? You have to take relative velocity. It's not simply velocity now, relative velocity. Now, what is relative velocity here? Scooterist is chasing the bus. That means whose speed is more here? Bus speed or scooterist speed? Scooterist speed is more compared to velocity of the bus because he is chasing the bus. When can he chase the bus? If his speed is higher, right? So both are in same direction. So take the difference. Scooterist speed minus bus speed. Distance is how much? 1000 meters. Time is how much? 100 seconds. So two zeros cancel. This is 10. Now scooterist speed is equals to 10 plus. What is the velocity of the bus? It is also 10. So 10 plus 10. How much will you get? 20 meter per second. So this is the speed of the scooterist. Once, just see what we have done here. Instead of velocity, just take the relative velocity. Why are we taking relative velocity? Because you are comparing the speed of scooterist with respect to bus. Comparison is made here. Relative, scooterist speed relative to the bus speed. So you have to take relative velocity. And both the objects are in same direction. So we are taking difference of them. Clear? Go through this problem. A train of 150-meter length is going towards north direction. So train is moving in north direction with, and what is the length of this train? This is 150-meter length. And with how much speed? 10 meter per second. A parrot flies at the speed of 5 meter per second towards south direction. So there is a parrot. It is traveling in south direction. How much is the speed of the parrot? 5 meter per second. So there are two objects under motion here. First object is train. Second object is parrot. And if you see their directions, both are in opposite direction. One is going towards north. The other is going towards south. Opposite direction. So what will be the relative velocity now? Opposite direction. You just have to sum of their speeds, right? So 10 plus 5, how much will it be? It will be 15 meter per second. Now, what is the question here? The time taken by the parrot to cross the train. So for crossing the train, how much is the distance that a parrot has to travel here? It's nothing but the length of the train, right? To cross the train, it has to travel the length of the train. So what is D here? It is 150 meters. You have to find the time taken. So very simple. Just apply the concept here. Velocity is equals to displacement upon time. But this time you have to take relative velocity here. What is relative velocity? 15. What is the distance? 150. Time we don't know. So what about the time now? Time is equals to 150 upon 15. So 15 one time, it is 10 times. So what is the time now? Time will be 10 seconds. So in 10 seconds of time, parrot will cross the train. Have you understood here? Any doubts? Please comment. I'll help you. See this question? It was asked in 2025 based on relative motion in 1D. So important concept. Two cities, X and Y, they are connected by a bus service with a bus leaving in either direction. That means in both the directions every t minutes. That means after every t minutes, a bus will leave the city from X, also from Y. So let us imagine this is X city, this is Y city, t be the distance between them. A girl is driving scooty with a speed of 60 kilometers per hour in a direction X to Y. So there is a girl. So she is traveling from X to Y. And how much is the speed of the girl? Let it be Vg. It is 60 kilometers per hour. What did she notice? She notices that a bus goes past her every 30 minutes. Okay. In the direction of her motion. That means in the same direction of the girl, the bus crosses after how much time? 30 minutes. And every 10 minutes in the opposite direction. So in the opposite direction, the bus crosses in how much time? 10 minutes time. Choose the correct option for the time period of the bus and the speed of the bus. So you have to find the speed of the bus and also the time period t, because after every t minutes the buses will leave the stops, right? X stop and Y stop. You have to find this t and the speed of the bus. Just see the question once again. Read it once. We'll split into two cases. Case 1, girl was going from X to Y, right? What is the girl speed? It is 60 kilometers per hour. Now in the same direction, bus was crossing the girl in 30 minutes time. So let the velocity of bus be Vb only. And what is the time given here? 30. Let us assume this distance as d kilometers. Now apply the relative velocity concept. Relative velocity is equals to distance upon time. What is relative velocity here? Bus is also in the same direction. Girl is also in the same direction. So it will be difference, right? So VB minus 60. Why not 60 minus VB? Because bus is crossing the gully. That means bus speed is more. So VB minus 60 is equals to distance. Let this be d kilometers. And how much is the time? Time is 30 minutes. 30 minutes means convert it into hours. So 30 into 1 by 60. So this is 1 by 2 hours. So 1 upon 2. So what is VB now? It is 2D plus 60. Let us take this as equation 1. Any doubt so far? Any doubt? No. Let us see the second case. Girl is traveling from X point to Y point, whose distance is d kilometers. Velocity of the girl is same, 60 kilometers per hour. But this time, the bus is moving in opposite direction. And how much time it was taking? 10 minutes. That means 10 by 60 hours, which is 1 by 6 hours. So in a time of 1 by 6 hours, this time the bus is crossing the girl in opposite direction. So what is relative velocity? Distance upon time. But this time opposite directions, I have to take plus. VB plus 60 is equals to D upon 1 by 6. So how much will you get? VB is equals to 6D minus 60. Let this be equation 2. Clear? Now equation 1, equation 2. Both stand for velocity of the bus, so equate them. So 2 is 6d minus 60, whereas what was 1? It is 2d plus 60. 2d plus 60. Send 2d that side, it becomes 4d. 60 this side, it becomes 120. So what is d now? 120 upon 4. 4 3 times 30. So this is 30 kilometers. So what is the distance between x point and y point? This is 30 kilometers. And what is the velocity of the bus? Use any of the equations. Use equation 1 or equation 2. It's up to you. Anything, anyone. We'll do one thing. We'll use equation 2 to find out velocity of bus. 6 into what is the distance just now that we got? 30 minus 60. So 180 minus 60. So how much do we get? 120 kilometers per hour. This is the speed of the bus. 120 kilometers per hour. So speed of the bus is available and distance is available. So what will be the time taken by the bus? Speed is equals to distance upon time. So time is equals to distance by speed. So distance is 30, speed of the bus is 120. So 30 by 120, 0, 0 cancel. So 1 by 4 hours. Clear? Everyone. So first we have calculated distance and then speed of the bus and then time taken by the bus. Why didn't we take here relative velocity, distance by speed of the bus? Because they are asking time taken by the bus. Okay. Already we found that velocity of the bus using relative velocity of concept. So don't apply the relative velocity again. Okay. So just see what we have done here. First time the bus is moving in same direction, time is given. So take relative velocity, distance by time. Next time bus is moving in opposite direction. So take relative velocity is equals to distance by time. So you'll get two equations, simplify them, you will get d and velocity of the bus. And then just substitute in time expression. So velocity of the bus is 120. There is only one such option. So directly your answer is D. But if you want to do, you can find out the time also. Clear? This was asked in 2025. So our first chapter is completed. Motion in one dimension. If you have any doubts, kindly post in the comment so that I will help you. Let's quickly recall what we have learned in this chapter. First, we have discussed basics of motion and then graphs of motion, equations of motion, motion under gravity, symmetry in motion, Galileo's concept of odd numbers, and relative motion. So I think you are fully gained the knowledge to solve the problems for your NEET exam. Okay. And if you found this series helpful, do share it with your friends. Practice the questions regularly because practicing is the key to master physics. Just listening and living the class is not important. Practice makes a man perfect, right? So the more you practice, the more better you become. Okay. And don't think of like studying this much, that much. No. Because the struggle you feel today, it creates a success you will enjoy tomorrow. Today you struggle and tomorrow you enjoy your success. And in the next chapter, we'll move to a new topic. So thank you for watching and see you in the next video.